let's say that this is our data structure where we have name, gender, wage, years of education, and a male dummy. What if we would like to explain wage by using the number of years of education? Then we can use the regress function, and our y variable is wage and our x variable is years of education. Now, this is our output, and we have 6 numbers of observations, and this probability of the F statistic is what we look at first. This is a joint test of all the coefficients on the x variables, the slopes, that they are all equal to 0. In this case, we only have a simple regression model in which we have one x variable. So this F statistic is the square of the t statistic. So these, the F test and the t test for the individual coefficient on years of education, will provide the same outcome. And you can see that by looking at the p-value of the F test, which is 0.16. This means that in 16% of the cases, then we would get an F statistic of 2.93 or more, given that our null hypothesis of this coefficient, the slope, on years of education is equal to 0. We get the same results for the t-test. The t-value is just the coefficient divided by the standard error. And in this case, the p-value of the t-test tells us that we get this result or something more extreme in 16.2% of the cases, given the correct, given that the null hypothesis is correct and this standard error is correct. So what we get here is the coefficient on years of education is 44, which means that given 1 unit increase in education, which is 1 year, then we would expect the wage to increase by 44. The constant here is negative. It's the value of our function, our regression function, given an x value of 0, which means 0 years of education.